Good day, everyone. Today I'm going to take you through logarithmic expression. We are going to look on how can we deal or how can we simplify logarithmic expression. Without waste of time, let's begin with our lesson. Let's say we are given number 1 is log of base A, B log of base A, C, let's say C and A, then log of base B, C, like that. How can you deal with this expression? How can you best simplify this expression? Number 1, if there is no any sign here and there as well, can you see the dots which are there between the 3 terms? If there is no plus or minus, just like here as well, if there is no plus or minus, any form of sign or divide whatsoever, if there is no anything, you need to know that there is multiply. Then now, if there is multiply like that, which means at some point we should aim cancelling maybe let's say like terms like that. Let's say another one is on top, another one is on bottom. That's where we can at least cancel. But now, which law are we going to apply to ensure that we have things which look alike so that we can cancel? We are going to apply the logarithmic laws which deals with changing of bases. Number 1, can you see that we have different bases? We have A, we have C, we have D there. Then let's change all these bases. The numbers which are just below the number, like let's say this is B, A, and C. The number which is quite little, or the number that which is quite small in terms of font, is said to be base. So now we have to change the bases to make sure that the bases are the same. I'm going to say log of base B over log of base A, log of B over log of A times log. Remember, I said if there is no anything there, it's like times, so I multiply the log of A over log of C multiplied by as well, like here, because there is no sign there, multiplied by log of C over log of B. Can you see that there's small b there? Then can you see that I had A, C, and B respectively as my bases, but however here I did not indicate any base. I did not put any base. If they are like that, you need to know that the base is 10. The base are 10. However, you can put any. You can even put 20. You can put, for as long as the base is not, don't put 0 on the exponent. Don't put 1 there on the exponent. Don't put any number that can be either 1 or 0, or a number that is less than 0. Negative numbers, don't put them there. So this is log. Then what I'm going to do now is one will say, why don't you, you can also put, let's say you can also put x there. Let's put x. One will say, why you choose x is of my choice, because I changed the base. I put anything. You can even put 2, can put even 3, you can even put any letter that appears there. But now I will just avoid putting a letter which is there, because I'll end up like causing some confusion whatsoever. So this is the first step. I changed the base. Now there comes an interesting part. What will I do there? What is it that I have to do there? Number 1, I'm going to look the one on top and the one on bottom. Then I cancel them if they are the same. So can you see that I have log of base x to a, log of base x to a, log of base b to x log of base b to x log of base c, log of base x to c, log of x to base x. Then I cancel them, they are the same. Now that I cancelled everything and there is multiplication in between, if they were plus or minus or whatever, and I cancelled everything, it was going to be 0. However, because there we have multiplied, if we cancelled everything, we are going to look on the coefficient. Since we don't have coefficient on our expressions, the coefficients will be like 1. So it's like saying the coefficient here is 1, 1, 1, 1, 1, 1, 1. So it's like 1 divided by 1, which is 1, 1 divided by 1 is 1, 1 divided by 1 is 1. So you multiply all those ones, you are going to get 1. That's it. This is how you can best deal with this type of logarithmic expression, the one without plus or minus in between. Then we will just need to apply the law of changing the base. We are going to look more on such things, but allow me now to introduce or to teach you or to share with you or to express a different logarithmic expression or to give an expression of different nature. Then now let's check this one. We have number 2, log of base 3 2 exponent negative 1. We have minus log of base 3. There we have 0.25. Then what is it that we have to do there? What is it that we are going to do on this type of logarithmic? We are going to, at first, we are going to change things that we can change, but the ones that we can fail to change, we will leave them like as they are. Okay, number 1, the negative exponent. Can you see that we have exponent there? The law says the moment you have a number with exponent there, the exponent simply will multiply its coefficient. So which means it's like the coefficient here is 1. It's like having 1 times negative 1. Let's say on the negative 1 there it was 20. It was going to be 20 times 1. Let's say it was a number, it was going to be the same number multiplied by 1. But now we have negative 1. So it will be negative 1 log of base 3 to 2. Then the 2 is no longer having an exponent. Minus log of base 3. Let's change 0.25. On the calculator, you can just say 0.25. You're going to get 1 over 4. But that 1 over 4, it can be written as 4 exponent negative 1 exponentially. This 0.5 can be written as, it can be written as 1 over 4, which can be also written as 2 exponent negative 2, which can also be written as 4 exponent negative 1. However, I will choose the one which is in the best interest. I cannot choose this one because there I already have base 2. I can also not choose this one because it's in the fraction form. I will at some point have to change it. But however, I will choose this one, the 2 exponent negative 2 there. Remember, this is part of rough work. Don't leave it like that because it will end up causing confusion to the marker or even yourself as well. So I chose the 2 exponent negative 2. The 2 exponent negative 2 is the same as 0.25. Then now, what is it that I will do? This is negative logarithm of base 3 to 2. Remember what I said the exponent times coefficient. Also here, I'm going to say exponent times coefficient of the log, which is the negative 2 times negative, which is positive 2 log of base 3 to 2. But now, one will be confused to say, why you multiply the coefficient, why you multiply the coefficient with the exponent? Remember, there is the chapter which is calculus. If you already done if you already done metric, or let's say you have done nated courses in N3, N4, whatsoever, above level 3, any level above level 3, or N3, or any level, maybe let's say level 4 on the NCV, whatsoever. There is this chapter called calculus, whereby we say exponent times coefficient, exponent minus 1. Here we are dealing with the logarithmic. We only multiply the exponent of a number with the coefficient of the log. However, we cannot subtract because we are not dealing with calculus here. It's different chapter or topic or whatsoever. So now here, what is it that I'm going to do? I'm going to factor out something that is common, things which are common. What is it that is common there? It will be log of base 3 to 2. So I'm going to say log of base 3 to 2 is the common factor. When I remove this, I'm left with negative 1 there, because it's like anything multiplied by negative 1 is the same thing. So here, when I remove this, I'm left with 2 there. It will be plus 2. So negative 1 plus 2 is a 1. Anything multiplied by 1 is the same thing. It will be logarithm of base 3 to 2. Just like that. Don't be confused. This thing there, it multiplies the whole thing. Doesn't multiply the 2, neither the 3. It multiplies everything there. But so this is how you need to simplify any form of logarithmic expression. For today's lesson, let me end here. We are going to do more with times, but for today, let me end my lesson here. Hope you enjoyed our today's class. See you in the next class or lesson. Thank you very much. Enjoy the rest of your day. Bye.